All right, let's dive into a topic that is absolutely essential for writing tests that are clean, reliable, and honestly just way easier to debug. We're talking about mocking and patching, the art of isolating your code so you know exactly what you're testing and why it's passing, or more importantly, why it's failing.
You know that feeling, right? Your car won't start. Is it the battery, the starter, maybe the fuel pump? When everything's connected, finding that one broken part can feel impossible. Well, software is exactly the same. A single test failure in a big, complicated system can send you down a debugging rabbit hole for hours. The real goal isn't just knowing that something's wrong, but knowing precisely where the problem is.
So here's our game plan for today. We're going to start with the core problem, what I'm calling the testing dilemma. Then we'll introduce the hero of our story, the mock object. After that, we'll see how to control it, how to put it to work using something called patching, and finally, how to use all these cool tools without shooting ourselves in the foot.
At the end of the day, a good testing strategy really boils down to one simple idea. Isolated problems are just so much easier to solve. I mean, think about it. If you can test one tiny piece of your code, a single unit, all by itself, you cut out all the noise and complexity.
This really gives us two big reasons for why we'd want to use mock objects. First, you want to isolate the specific bit of code you're testing from everything else it talks to. We call those its collaborators. And second, you really want to avoid using things in your tests that are just a pain to deal with.
And that second point, it is a huge deal. Seriously, do you really want your simple unit test to connect to a shared database? Or start writing files to your computer? Or make a real API call to a cloud service that costs money? No way. It's slow, it can be expensive, and it introduces all these external variables that could make your test fail for reasons that have nothing to do with your code.
So how do we get around this? Well, we bring in a stunt double, and that's exactly what mock objects are. They're stand-ins that can pretend to be those complex, expensive, or just plain annoying collaborators, letting us test our code in perfect, beautiful isolation.
So in Python, the mock object comes from the built-in unitest.mock library. You can think of it as a completely blank slate, a piece of clay you can mold into anything. You can use this thing to replace literally any object in your code, whether it's a simple function or a really complex class.
Now here's where the real magic happens. Mocks work on the fly. If your code tries to call a method like .get_user_data on a mock, you don't have to define it ahead of time. The mock just creates it right then and there. It's this incredible flexibility that makes them so powerful. They can mimic any interface your code expects to see, instantly.
But, just having a stunt double isn't enough. You have to be the director. You need to tell it what to do. So now that we know what a mock is, let's look at how we can control its behavior and, just as importantly, check what it actually did during our tests.
We basically have three main levers we can pull. First, we can inspect its usage. We can ask the mock things like, hey, were you ever called? How many times? And what data did you get? Second, we can control what it gives back using its .return value. And third, we can define more complex actions, like making it raise an error, using .sideEffect. Controlling that return value is a game changer. For instance, imagine you're testing some code that behaves differently on a weekday. Instead of worrying about what day of the week it is when you run your test, you can just mock the calendar function and force it to always return, say, a Tuesday. Boom! Now your test is totally predictable and will give you the same result every single time. Okay, so we've got our super talented mock objects ready for their close-up. But how do we actually get them into our code to replace the real things? Well, that's where patching comes into play. Patching is the actual mechanism that does the swap.
The patch function from unitest.mock is our main tool for this job. You basically tell it what object you want to replace and where it lives. Then, just for a little while, either for a whole function or just a few lines of code, it temporarily swaps out the real object with a mock.
And you've got two main ways to use it. You can use patch as a decorator, that little @ symbol above your test function. That applies the mock for the entire test. Or if you only need the mock for a small part of your code, you can use it as a context manager with a with statement. This is great for keeping your test really clean and specific.
Now this brings us to what I call the golden rule of patching. And I'm serious, getting this right will save you so much time and frustration. You must patch an object where it is being looked up, not necessarily where it was first defined. This is the source of pretty much every patching headache out there. Let me say that another way because it trips everyone up at first. It's not about where the object was born, it's about where the code you're testing goes to find it. So if your main app module imports a function called helper, you need to patch main app.helper, not the original helper that lives in its own separate file. You patch the lookup location. Mocks are amazing tools. They really are. But you know what they say? With great power comes great responsibility. If you're not careful, mocks can lead to tests that pass but give you a totally false sense of security. So let's talk about how to use them safely.
Here are the big risks. Because mocks are so flexible, your test can slowly drift apart from reality. For example, if you misspell a method name on a mock, the mock doesn't care. It just creates it for you, and your test passes. But then your real code crashes in production. Even worse, if the real object you're mocking changes, your tests won't know, and they'll just keep on passing, hiding a critical bug.
So, what's the solution? We need a safety net. And that's exactly what the spec parameter is. When you create your mock, you can give it a spec based on the real object. This makes the mock much stricter. It'll now throw an error if you try to use any method or attribute that doesn't actually exist on the real thing. It's what keeps your mocks honest.
And as we finish up here, I think it's worth remembering this classic bit of wisdom from the computer science giant Edgar Dijkstra. Testing, even with amazing tools like mocking, is all about finding bugs. It can't ever prove that your code is perfect. It's a tool for building confidence, not for achieving some kind of absolute certainty.
So we've seen how mocking lets you get this perfect isolation for fast, clean, and reliable unit tests. But the real challenge isn't just writing them once, it's making sure they stay relevant over time. Using tools like spec is a fantastic first step. So the question I'll leave you with is this: how are you going to make sure your tests evolve right alongside the code they're supposed to be protecting?